Donc, bonjour, bonjour à tous. Merci d'être présents aujourd'hui pour le webinaire. Je m'appelle Amy Desilets, je suis directrice adjointe à la recherche aux producteurs laitiers du Canada.
I work in research at the Dairy Farmers of Canada. This series of webinars is organized with DFC in collaboration with Acer Consulting. Today, we've got a seventh session out of 15. We talk about dairy production, research projects funded by DFC and other partners. Additional details on our upcoming events will be shared at the end of the webinar. And today, we will look to the well-being for dairy farmers. I'd like to remind you that this is a traditional Zoom meeting, which means that you've got the possibility of opening your cameras and your microphone. For audio quality, this said, we would like you to stay with your mic off until you are ready to ask a question or make a comment. And you can send us your questions in the chat as we move forward, and we will do our best to answer all of these questions while near the end, so during the round table. Contrary to the previous webinar, for those of you who are not here for the first time, today, our speakers will present mainly in French, with the exception of our one speaker who will speak in English. For those of you who want to listen in English, you can have access to the interpretation function by clicking on the interpretation globe at the bottom of the screen and select the English language, and you can deactivate original audio. If you need assistance for any technical problem, please don't hesitate to contact Steve, Julia, or Carly from the Acer team in the chat function at the bottom of your screen. And please note that today's event will end at 2:45 and includes individual presentations from different researchers, followed by a discussion. This series of webinars is made available thanks to partnership with agriculture and the dairy research group with Agriculture Canada. So big partners are Agriculture Canada, Dairy Farmers of Canada, the Dairy Gen Lactanet Advisory Board, and Novalet. So without further ado, I'd like to present you to our first speaker of the day, Dr. Elsa Vasseur. She is an adjunct professor at McGill and in Novalet Industrial Research with Valacta and DFC on dairy farmer research, and she has been a member of the chair since 2016. University work is multidisciplinary for her. Her experience is numerous. So applied science in animal behavior, animal welfare, and measures around appropriation and well-being of animals, longevity of animals with other components involving sustainability, so environmental and social factors, and knowledge transfer methods and technology transfers that will help with the adoption of new practices by producers. On that, Elsa, I'll turn the floor over to you. Thank you. Thank you for the introduction. It's a pleasure for me to be able to talk to you. I've just got a couple of slides, but I wanted to tell you about the key points of the project, and then the team will take on everything else that we do. So we want to talk about how we can redefine interior and exterior spaces for cows, and by developing better management practices. It's interesting. We look at tie stall, and the results that we have are in research projects that continue, and we do want to have models around tie stall and freestyle. So we have some main goals. So welfare, identifying how we increase locomotion possibilities, what it means for lameness, what it means for other elements of well-being, welfare, emotions, thermal stress, heat stress, etc. And in all of this, we want to understand how we can work with engineers so that we can say, okay, how do we develop these spaces internally and externally? And what do we do to minimize the ecological impacts if they're negative? And so we want to look at reducing the footprint on the environment, so energy, water, etc., and also how we can conceptualize different systems that are more sustainable. We've got an entire team behind us. The whole thing began with Stéphane Godbout from IRDA, and we have KPI, University of Laval for the economic portion. CRISAD, Steve Nadon has been with us since the beginning, and two other people from Agricultural Canada. I just wanted to mention all these great people who have been working with us for so many years. Next slide, please. Next slide, please. Funding. This is from the group. We have projects that continue within the context of two initiatives. So we've got the Teaching Leadership Chair, led by Sébastien at Laval University, and Sustainable Living at McGill. So let's look at Marjorie's results. How did we do? Did we increase opportunities? And what exactly did we do for all of this? Let's take a look at some of the results. Thank you very much, Elsa. Like you said, we're going to move on with our next speaker, Marjorie Cellier. She's a postdoc researcher. She has a doctorate from Paris in France, and she works on biological models in diversity, so captivity, cows and goats in captivity. And we look at different domains of interest, including social behavior, mooing, and behavior, feeding behavior. She is currently doing research on the emotions and the locomotion in dairy cattle living in an environment where locomotion is restricted. Marjorie, the floor is yours. Can you see my screen? Okay, thank you very much for this introduction. My name is Marjorie Cellier. Today I'm going to show you the results of our research that we have, so locomotion, and when they have access to a lot where they can exercise. So when you look to consumers and what they think cows should be doing, this is the image that they have. But the reality is that all producers cannot provide such conditions to their animals. In addition to that, most of the dairy farms in Canada are in tie stall. And so there will be a limit around locomotion, and the animals will have less freedoms, but when you have more freedoms, it's harder to put that into place. And so we have other solutions that exist to be able to reduce this restriction of movement. For example, the fact that we're modifying the size of the stall, the length of the chain, or providing access to an exercise yard to increase comfort and
Donc, l'accès quotidien à une aire d'exercice, que ce soit une aire d'exercice intérieure, un enclos extérieur ou même un pâturage, peut permettre d'augmenter l'activité.
Cows who are moving around, we can see that there are benefits, but we also have opportunities for natural behaviors to come to the surface. Now, this exercise is also a form of environmental improvement. So we also don't really know how access to exercise for cows that are constantly in an environment that limits their movement can increase the level of locomotion, and what conditions are favorable when it comes to the duration, the type, and what types of impacts and influences we could have on cattle when they are more mobile. Also, when we talk about outside access, some producers don't see this access as positively. And so just to quote when we look at some of the impacts or the impact on the environment, we can see that there are obstacles when it comes to supplying external access while the cows are on the farm. Now, favoring the adoption of producers to this type of practice means that we're always, if we're only looking at the locomotion expectations of clients, we do need to, or customers, we do need to look at the benefits of having access to an exercise yard, but also relative to the different access conditions when it comes to accessing this exercise yard. So it's in this context that we started our study. The goal was to quantify the impact of the possibility of movement outside of the stall and the impact on cows who are in an environment where movement is limited, and then to assess what conditions of access to exercise improve locomotion. So we'll talk about the types of exercise yard, the size of the exercise, and the length of time that the cows are out. So to answer these goals, we did accomplish 6 experiments between 2019 and 2021 with Holsteins who were constantly in tie stall situations. We did testing at different seasons in
différentes. Et on avait différentes conditions d'accès.
And the summer, and we had different access conditions to exercise. So you could have an exercise yard outside versus not having access to that exercise yard. And then we could have different data for length of time. So 1 hour, 2 hours combined with different sizes of the exercise yards. And so in different, 20 square meters to 80 square meters. And then we had outdoor versus indoor exercise places. And then we looked at all these conditions to be able to understand the conditions and make sure to understand what was representative. We looked at locomotion. We looked at the number of steps and the different types of things that we could get. And so the first question that we see is, do we see that cows will do more when they have access to an exercise location, and compared to when cows are either in the exercise yard or not. So here, the cows have more steps per day when they have access to exercise, even if we see that there's a certain variability between our tests, and that's what's represented by the different colors on this chart. More specifically, we saw that the cows with more than 300 steps per day had access to exercise. Now, first of all, we could say that 300 steps per day could be equivalent to what we do when we're doing exercise, when we leave our house and we go into our car. It's the first thought that I had. But then I looked at the number of steps under a ratio context. And when we look at a ratio, it's an increase of 50%. And so cows, when they spend 4% of their time in an exercise yard, so 1 hour per day, they completed 50% more steps than what they do when they stay in the stall. If we look at the different access conditions to exercise yards, we start with we look at the amount of steps that they take when they're in an exterior exercise lot versus interior. And so looking at different factors, we can see that there were different approaches in terms of complexity. You can see here that you have to walk around to get to the exterior yard versus the interior and the type of surface. So we had a change in flooring when we were outside versus indoor. And the characteristics could have an influence on the reaction of the manipulator and have an impact on the behavior of the cow. Another factor that could really have an influence on this result, and that outside could be more stimulating than indoors, specifically with new elements and other things that could seem to apply much more frequently outside than inside. And so if we look at the size of the exercise yard, we saw that cows took more steps when they were in a bigger exercise lot, and more specifically when we quadrupled the size of the yard, so from 20 square meters to 80 square meters, cows took on 16% more steps when they were in that situation. And also, if we look at the comparison between 1 hour of access versus 2 hours of access, we noticed that when we added the second hour, cows were going to walk 9% more steps daily than otherwise. And so we did see that the cows will take 50% more no matter what the conditions of access. When they're outside, they work 20% harder for the feet or for the steps. And when they're in a big space, it's 16% more. And when you add a second hour of exercise, then 9% of the time they are also doing more. What we determined was that the cows are not going to spend their hour walking. So what do cows do when they are in an exercise lot? That's the big question. So we looked at that, and what we noticed was that the cows spent a third of their time walking. So not just walking, but they explored and undertook social behaviors. And what we determined as well was that they spent most of their time being inactive. Now, inactive doesn't mean that they do nothing. They could take little steps. But this result is interesting because it allows us to introduce the notion of utility. In fact, when we are in exercise lots, it allows the cows to have social contact. It increases the newness in their routine. And when this newness is gone, then the cows didn't have much access to food, water, or shelter, and so no additional stimulation. So maybe over the course of time as well, the interest and the utility of exercise lots could decrease. If the goal to supply exercise is to maximize behavior, then different type of enriching behaviors or resources should be added to stimulate and renew the interest of the animal in these exercise lots when they are in them. So what are the important points to retain from this presentation? Well, first of all, expectations change in Canada, and producers need to be supported in these changes with new scientific knowledge. That's why this study is so important. Now, we also showed that providing access to exercise for an hour a day with different conditions had a major impact on the quantity of walking by a cow, and it led to other types of behaviors as well. And you also have to keep in mind that the additional resources, so water, food, shelter, could provide more enriching experiences for cows in these exercise lots, therefore improving the advantages around animal welfare, cow welfare, and locomotion. So that's the end of my presentation. Thank you very much to all of the players who allowed our research to take place, and obviously all of the people who participated in all of these studies. And thank you very much for your attention.
Merci à toi, Marjorie. On poursuivra.
Thank you, Marjorie. We will now hear from Elizabeth Chavez, a doctoral student at the University of Laval. She's a biochemist with Celaya in Mexico. She has a master's degree in biotechnological innovation at the Jalisco State Science and Technology Center. She has been studying Earth and environment at University of Laval. Elizabeth, over to you. Hello to all. Can you see my screen? Yes. Okay, great.
Bonjour à tous.
Hello to all.
Le projet s'appelle Conception d'un enclos d'exercice extérieur alternatif pour vaches laitières
We are looking at designs
au Québec.
for cows in freestall in Quebec and exercise for dairy cattle.
Donc, la province de Québec est le plus important producteur de lait, mais les fermes au Québec
Quebec produces a lot of milk,
environ 80%. Mais ce
around
système est
80% of the milk.
parce qu'il y a des impacts
But the
sur la
system is
santé
questioned
des
because
animaux,
there
comme
are
surtout
impacts
la
on health
vaches
and
laitières.
animal welfare,
Et une
like
solution potentielle consiste en offrir
disease and
l'opportunité de
lameness.
mouvement à longueur d'année.
But we want to be able to improve movement across the year. That's one of the potential solutions to improve things. We have a lot of support, and one of the options is to build a barn, but that's expensive. So we also want to look at pasturing. And for farmers who don't have access to that, there needs to be a good study on rules. REAs, agricultural operations rules need to be followed. We also have to have good draining, good drainage. And we need to have what we call standoff pads. Any other alternatives could be good filtration to retain contaminants in these standoff pads in Quebec, and then looking at the air injectors and filter materials. Now, it's important to reduce the cost of construction, so drains and geomembranes, but also to decrease the volume of water that needs to be managed. The project is composed of 4 phases. Phase 1 is to assess the concept of standoff pads and all quantities of water. Phase 1 is with the farm CRSAD, so Deschambault in Quebec. And we looked at cows for an hour and a half in the morning and in the afternoon, and looked at the filtering materials. That means that it's conventional materials. The experience lasted 9 weeks in the winter and 9 weeks in the summer. We looked at the sodium during draining to measure the quality of water and the lixivian blooms. For phase 2, the goal was to assess the performances of different types of filtering materials to improve filtration and retention of manure. The testing happened at the IRDA Scientific Complex in Quebec City, Quebec. We looked at synthetic cow manure. The testing happened in the laboratory in Quebec. And we looked at different sequences. You can see one of the images here. And during 3 weeks, with 5 treatments and 3 repeats, that's what we did. After that, we undertook phase 3. The goal was to establish the impact of air injection into biofilters with the selected filtering mix and conventional materials. So we were in Deschambault for 3 weeks, 1 time in the winter and 1 time in the summer for 3 weeks to simulate summer. And semi-synthetic manure was used because manure was recovered from a farm in Deschambault, but it was difficult to recover anything else. So it was a mix of manure and tap water. You look at the 2 filters that we used in the right image, and we had a drainage pipe 3 meters in diameter in each room. And alternative and conventional materials were used in the filter. That means that we used conventional materials in phase A And a second mix was used. Oh, sorry, I didn't want to do that. And we used a second mix in the materials for the filtering materials. And that was result of phase 2. We used the same results for phase 3 and for the alternative approach. For the last phase now, the goal was to evaluate the standoff pads as modified compared to conventional wintering stalls. This was the Cresad farm, same phase as phase 1. And we looked at 28 square meters per cow. And materials were changed, and we used alternative filtering materials from phase 3 for the last phase. And then in the photos on the left, we look at modified standoff pads versus on the right, where you have a wintering stall conventionally. We used original soils, and the testing happened over 9 weeks in the winter and 9 weeks in the summer. And the cow came out 1.5 hours in the morning and 1.5 hours in the afternoon in the same way. Now, with regards to results on the quality of water, in phase 1, you can see the first chart on the left. You have the oxygen testing during the summer, and it's higher in the standoff pads that are aired out. On the right, you see these suspended solids, and there was no significant difference. And then with regards to volumes, the standoff pads that were aired out, there were more volumes than the non-aired out standoff pads. For phase 2, in the first case, it's control, and then you see the wood chips and biocarbon in the second case. This is the phase 2 on the right. And then we've got grasses. And in the third case, we've got the wood chips plus sand. So in the chart, you have a reduction in contaminants as a percentage. So for treatment with sand, we noticed that it was more effective for phosphates and solids, but as of the third week, it started to get blocked up, and it was no longer efficient for filtration. After that, we had the treatment with wood chips, and that was good for chemical demand in oxygen and total nitrogen. And then with biocarbon, it was more efficient for retaining nitrates. After that, we had results for phase 3. In the first chart, you can see the oxygen, and there's a significant difference between materials that are conventional materials, in other words, wood chips materials, and material that is alternative materials. So there's a significant difference between the two materials for both sessions.
On peut voir la rétention de contaminants des solides, donc de façon similaire à la première
Similar
graphique.
way to the first graph, there's an important difference between the material, conventional ones, and alternative material for both sessions, but there's no difference. There was no significant difference in view of the ratios. In terms of phase 3, phase 4 rather,
On peut voir la concentration de demande de
concentration of oxygen for conventional and modified ones. So here we can see the results show that organic matter has not improved. It's 3 times lower than in conventional ones. And now, as to the volume that we see in the last graph, we can see the volume is, just a moment, the volume well, as you can see on the screen, compared to modified ones. Conclusion for the 4 phases is that all configurations of standoff pad in water contaminants, but not enough to be directly dumped in the environment. Air injection in the stable does not improve significantly filtration of contaminants. And the third one, the third alternative with wood chips increased the retention of volumes, but it compacts easily. So we have to change the material to avoid compacting. So that's it. Thank you. Thank you for your attention. Thank you, Elisabeth. We'll continue with Catherine Diaz, the University of Laval, doing a doctorate. She has a master's in agriculture from the University of Columbia. She's studying in soil and environment at the University of Laval in Quebec, and her topic is on validating simplified measures for gas emission in animal systems. So, Catherine, the floor is yours. Well, thank you very much. Is this all right? Yes, very, very good. So thank you for this presentation. I'm Catherine Carranza, and I'll present you a title talk, emission of gases coming from outside exercise yards, conventional, and the alternative for cows in tie stables. So the context, the environmental impact of the industry, 3.7% of greenhouse gases in Quebec, 3.7 in Quebec, 1.3 in Canada. So when we look at the carbon footprint in Canada, it's 1.01 kilogram of carbon dioxide, and the water footprint is 20 liters per each kilogram of milk. So the question is, adding exercise yards outside, will that modify this level? And in view of this context, the goal of this study is to quantify greenhouse of ammonia through conventional and alternative exercise yards compared to standoff pads indoors and outdoors. So the methodology experimental site, this project was done with 34 cows from the Beauchambeau Animal Research Center in Quebec. As we know, this project was divided in 4 phases, but greenhouse gas and ammonia were in phase 1 and 4. In phase 1, we determined the type of stalls, outdoors and indoors, was preferable to offer exercise to cows with a lesser environment on the environment. So this was done in 2020. In 4th phase, we did so. Well, as you can see on the screen, with conventional standoff pads. So a standoff pad, but improved. We did so in 2021 and during the winter of 2022. Emissions were measured once a week for 9 weeks, both in the summer and the winter. Just a second. In terms of sampling of gas in the ground, this was done by looking at a closed chamber method, and we've been able to collect and analyze for ammonia and greenhouse gases. So this is for gases acquisition, and to the analysis, it's all the And for ammonia, the acquisition is done by ammonia level, and we use colorimetry to analyze this. We'll see greenhouse gases sampling. So here, we started with sampling here. Those greenhouse gases were collected every 10 minutes for an hour. And finally, to quantify the gas, this was done, as I already said, by using this methodology that we see on the screen. Now, we'll look at the procedure for ammonia. So for this, part we'll say in sulfuric acid trap to find out the amount of ammonia in the air, and we have a closed chamber that sends it to a pump to find out the amount of ammonia generated in this chamber. In this technique, we capture ammonia, and the concentration of ammonia, the NH3, is calculated by using this formula. The result for phase 1, we can see CO2, carbon dioxide enclosed is higher. We've observed there's a higher quantity of methane in internal or indoor conditions like the stall. And we observed that outside conditions showed some lower emissions compared to indoors, like stalls. And there's no difference in ammonia emissions in either cases. In phase 4, except for gases, we had higher emissions, and in the summer, ammonia emissions remained similar in terms of carbon dioxide. The alternative stall at a higher level because of cow breathing, which added to what was in the air. And finally, in the summer, the conventional stall had methane emissions higher, seeing as they operate inaudible. Apologies. And in conclusion, in the summer, phase 1 and 4, with injecting air coming from the stall or the alternative stall to the type of standoff pad, causes CO2 coming from cows breathing. And in the summer, phase 4, conventional stall brings about a production of methane and ammonia higher because the anoxia conditions are improved or favored. And in the summer, in phase 4, the stalls presented a greenhouse gas emissions and ammonia higher because the air was circulating less than in the summer. Finally, to answer the question of this context, alternative standoff pads improve. It improves the air quantity, but does not have an impact on milk production. So thank you very much for your attention. Thank you, Catherine. So our next speaker, this will be Emir Ratti, has a master's degree at the University of McGill. Emir's presentation will be in English. So we'll ask for those who are listening in French to go to the bottom of your screen, go to the globe icon, and select the French option to listen to the interpretation into French. Once he'll be done, you can use the same icon to come back to the main audio channel. Amir is a dairy expert in freezing group in BC with years of experience as a vet. He also has a master's in animal science from the University of McGill University. EMIR focuses on cow comfort, hoof care, and nutrition. Let's listen to EMIR's presentation now.
Il n'y a pas de son. Hein. There's no sound here.
We're just working on that.
On va donner quelques minutes à la technique pour essayer de régler le problème.
Hello, everyone. My name is Amir. I'm a dairy specialist here in BC, and it is my honor to be one of the speakers presenting the results of our research project at McGill University. This study was part of my master's.
Le but de cette étude, ça faisait partie de ma maîtrise et j'attends avec anticipation partager ce qu'on a vu, comment l'accès a un effet donc sur les sables.
As you know, intensive livestock farming was established to sustain the growing population, but relocating animals from their natural habitat to intensive housing, indoor housing, has resulted.
Mais en confinant des
is becoming a growing concern for animal welfare. Cows housed in indoor housing system are experiencing different level of locomotor activity. Obviously, tie stall barns are the most restrictive housing system, but even in more open housing systems, such as freestall barn, cow may face limited roaming space due to, for example, overstocking, which is kind of a common issue here in North America. So returning to tie stall barns, they still make up a considerable portion of dairy barns here in Canada, and we know that switching from a tie stall barn to a different, to alternative housing system with either loose housed or continuous pasture access is not a straightforward process. So one of the solutions to mitigate this restriction could be partial access to outdoor, which offers additional space for increased movement and activity within an indoor environment. Access to exercise areas has been shown to improve behavior, health, and welfare. And we know that cows like to move, and when they're tied up and can't move, it can harm their behavior and probably their walking ability. So the question here is that could access to outdoor improve her moving ability? And how does it affect her gait and hoof health conditions? Gait abnormality or lameness, as you may know, is a prevalent issue and a major welfare concern in dairy cattle, causing significant economic losses. Gait abnormalities can be identified and evaluated using gait analysis techniques like visual gait scoring, and also, as you know, assessing hoof health helps evaluate gait problems using clinical examination, or technologies such as hoof tomography could also help to identify gait abnormalities. Previous studies found that providing stall house cows with pasture access results in a lower likelihood of lameness. However, most of these studies have been conducted in free stalls and on kind of clinically lame cows. And limited information is available on the effect of partial outdoor access on gait and hoof health of non-clinically lame cows housed in a movement-restricted environment like tie stall barns. So the objective of this study was to evaluate how regular access to an outdoor exercise yard affects the gait and hoof health of lactating cows housed in a tie-stall barn, and to assess the gait, we use visual gait scoring, and to assess hoof health, we use claw lesion assessment and hoof tomography. For our study, 30 cows were divided into 5 groups and randomly assigned to either exercise with outdoor access or remain indoors. Outdoor access for exercise cows was provided for 1 hour per day, 5 days per week, and for 5 weeks. This slide also shows the timeline of this study, and we collected data mainly in 3 periods: pre-trial, post-trial, and follow-up. For visual gait scoring, we performed the visual gait scoring using video recordings. The gait was evaluated using 0.5 interval NRS for an overall gait score and 6 gait attributes: swinging out, back arc, tracking up, joint flexion, asymmetric gait, and reluctance to bear weight. For claw lesion assessment, we conduct a claw lesion assessment through full hoof trimming at pre-trial and follow-up 8 weeks after the trial. The number, location, and severity of lesions were recorded by a trained observer. Thermal images were taken from dorsal view of coronary band of all cows enrolled in the study with a high resolution thermal imaging camera. Folder E8, and this data collection was done at week 1 and week 5 of the study. Thermal images were analyzed using a specific software, thermal software, and 4 thermal variables were extracted for further analysis. Here are our findings from the study, and for gait scoring, we analyze the changes occurred in scores. As you can see in this graph, changes in the score between post-trial and pre-trial periods. Yellow represents our exercise cows, and blue represents our non-exercise group. The exercise group showed a numerically improvement of 1 score for the overall gait score after 5 weeks of outdoor access, and the improvement persisted over the time for 8 weeks after the trial. However, the changes in the overall gait score and the 6 gait attributes were not statistically significant between the groups and over the time. The same pattern was seen for 3 key gait attributes: tracking of asymmetric steps and reluctance to bear weight. We saw a positive effect of outdoor access. Our gait scoring findings indicate that utilizing outdoor access may lead to an improvement in gait scoring, and lack of significant difference in gait scores may be due to factors such as selecting against lame cows, so limited room for improvement in cows with lower scores, and also a small sample size and limited duration of treatment comparing to seasonal or year-round studies. Our claw lesion results showed a total of 38 claw lesions at 2 data collection periods, and all of the observed lesions were sole hemorrhages. As you know, sole hemorrhages are considered kind of a less severe lesion comparing to the other claw lesions. A statistical analysis of claw lesions showed that neither prevalence nor severity of sole hemorrhage changed for both treatment groups from pre-trial to follow-up. So we saw no negative or positive effects of our exercise treatment on hoof health. On one hand, we can say that our study suggests one hour in daily outdoor access doesn't increase claw lesion risk. On the other hand, no improvement in claw lesions observed due to low prevalence, and so limited room for improvement. Also, we don't know, to be honest, that if this level of partial outdoor access could improve hoof health comparing to seasonal or year-round pasture access. For tomography, we use a new method to only look at the changes in temperature, possibly the increased temperature as a result of laminitis during the trial. The results showed no difference in hoof temperature variables between treatment groups after 5 weeks of outer access. All thermal images, however, were statistically affected by ambient temperature, which was consistent with previous studies. The result collaborated our collagen result, the hoof tomography result, and our results showed that providing 1 hour of outer access for 5 weeks did not lead to detrimental effects on hoof health. In conclusion, the exercise cows showed improvement of 1 to 1.2 scores in the overall gait score and 3 main gait attributes. And this improvement persisted for at least 2 months after the trial. And the use of hoof tomography for detecting subclinical signs of claw lesion collaborated our claw lesion inspection, and our study suggests providing at least 1 hour, one
Offrir
hour
1 heure d'accès à l'extérieur.
to detrimental effects on hoof health. However, more investigation is needed to see what level of outer access could yield positive outcome for toy-style dairy cows. Thank you for your attention, and unfortunately, I won't be able to attend this event, but I'm sure that our team will assist you with any question you may have.
C'est ce qui complète maintenant nos présentations. On passe maintenant à la période du panel de chercheurs qui comprendra Dr Elsa Vasseur et Marjorie Sellier qu'on a entendu précédemment, ainsi que 2 autres panélistes, Sébastien Fournel et Stéphane Godbout. Sébastien est chercheur en génie agricole et bioprocédés avec une expertise en contrôle environnemental des bâtiments d'élevage, élevage de précision, conception d'installations agricoles, gestion du fumier, bien-être animal, atténuation des gaz à effet de serre à la ferme, valorisation des résidus agroalimentaires et la biomasse dans l'énergie et les bioproduits et la qualité du sol, de l'air, de l'eau, des exploitations agricoles. De son côté, Stéphane cumule plus de 20 ans d'expérience en recherche et développement en génie agro-environnemental. Ses travaux de recherche portent sur les stratégies d'élevage et de gestion des déjections animales, principalement dans le domaine des rejets des systèmes de production animale tels que les émissions de gaz et les odeurs. Excusez-moi. Donc, pour lancer la discussion, nous avons préparé quelques questions pour nos panélistes, mais si vous avez des questions pour nos chercheurs, veuillez utiliser la fonction de chat pour poser vos questions et nous les intégrerons à la discussion. Toutes les questions auxquelles nous n'aurons pas le temps de répondre, une réponse sera envoyée par courriel suite à la rencontre. Donc, commençons par une première question pour Elsa. Nous avons pu voir dans les
presentations on animal wellness that providing daily access to exercise yard will double the locomotive activity and it will be beneficial to the health, the hoof health. Are there other benefits that you saw and observed within your research? You're on mute, Elsa. Okay, this is better like this. Yeah, that's better. Yeah, indeed, right. Right. This was good news, as you just said. We discovered through our exercise access to exercise also will be helpful. What we found is that when animals go out, the animal, for instance, is being handled more. There's more relationship between the producer and the animal sees new situations like unforeseeable one. that you see outside. However, what we found, it's the way we manipulate animals when they go out. That's crucial in the animal's activity, with the idea that the cow has to see this as a positive experience going out, so that this becomes easier to remove the cow, can go outside. So to take the time when you get them used to it, to give them a chance, the cow have a chance to learn that this is new, and to use force is not a solution in the long term. What we see is that the cow will not understand what's going on if we use force, what should be done. And so this will loop, so animals become more difficult to handle. So when we do this right, when we take the time to do it well, I think it works well. I think it's important that we share these viewpoints also for producers who are listening to us. If you have some concerns as to how, yes, we can do this, and we have to take the right time to do it. All right, thank you, Elsa. And to add to this, I'd say, well, you just mentioned that the cow has to see this outgoing as a positive experience going outside, for instance, so that the handling becomes easier. But how does the cow perceive, in fact, this going out? I'll ask this question to Marjorie. Yes, I'll answer this one, because in fact, to know how the cow will see this, we use two tools to assess the behavior. So before and while this is going. So the first step is the animal learns that going out is coming up. The outgoing is going. So we'll put a routine in place with indicators, like, for instance, maybe preparing the stall for the animal to leave. Once the animal understands this, we'll look at their behavior. Once they understand they're about to go out, to see if, for instance, they're more agitated compared to when they don't go out. So because the fact that they're agitated, this could translate to anticipation. But again, we don't know if this anticipation is something that is perceived positively or negatively. So to have access to this information, then we'll look at the second issue, motivation. To look at motivation, for instance, when they'll go outside, we'll look at how it's unfolding on the ground, the time spent to go outside in the exercise yard, the behaviors the cow will have. Will the cows try to stop? Will we have to encourage the cows to go out and move forward, etc.? So all this, we looked at this in our research, and what we saw is that there could be various motivation profiles, meaning some cows which will be more or less enthusiastic to go outside. But as Elsa mentioned just before, in fact, the way cows will be handled to bring them outside, again, that's a factor that's most important. This will influence, if you will, the perception the cows will have of this outing. So to know how the cow will perceive this, we can use these two tools, anticipation and motivation, to have access to this yard.
Merci, Marjorie, pour la réponse. J'aurais maintenant deux questions.
Thank you, Marjorie, for your response. So 2 questions from an engineering standpoint. The first one is, the results presented by students showed that the concept of standoff pad is a valid external option for exercise in cattle, and works on rejection to the environment, but it's not conventional all the time. However, how much could it cost when we have this type of technology? I can start with an answer if you'd allow. Yes, Sébastien, please go right ahead. Well, we're still doing an economic assessment, but the preliminary numbers that we have currently state that with regards to phase 4, so the improved standoff pad, filtering, gravel, drainage system membrane at the base, or where filtering materials have been modified. And so we've got wood, carbon, etc., with the implementation of an aeration system coming from the barn. Well, that cost about $14,500 for the 28 square meters that were tested. So about $500 per square meter. In comparison, in the winter, all the traditional approaches that are used in dairy, like for that, we just before the stall side, we were be around $10,000 per square meter, so it's about $350 per square meter, and so we've got a number of a lot of money that we've got the methanization from the soil, the geomembrane that was in the original concept, and that leads to certain types of contamination flow in the environment when you've got quick freeze thaw. And so we've been working with different groups, and we also, over the past few years, and we also have for the standoff pad system, it requires excavation so that you have something at that level. And in our concept as modified, there was that whole concept of aeration system that recognized the air from the adjacent. And so you had fan air that dealt with all of the different aspects so that you could reduce the risk of spreading pollutants. But you have to know that even if it's more expensive, traditional stalls in the wintertime could be associated with a vegetation filtering band so that you can use that at some point, and that's in addition to, so it's an additional cost. And this assessment is made based on the concept of improved situations, and so the mix that allows for better filtration, but with retaining the water volume. So if we can't hold if we can't have treatment with quality water where we send water into the environment, then we need to cover it or grab it and put it into a reservoir and have a mix where you can optimize the situation. However, there's a situation which we're talking about square meters of filtering. For the wood, it's about $200, whereas the mix was approximately $300. And then if we think about the wood chips, you can reduce the cost around building. And so it's adjusting the system. And then the aspect that was not yet studied and needs to be used in the next phase is the whole question of frequency of replacement. So according to temperatures, the wood chips can be used for approximately 6 months. And so you change it in the wintertime and then for the summertime. Whereas for the mix is different and it compacted very, very quickly and easily. And so it does get compacted really easily. And so you end up having a higher risk of change. And what's important to mention as well is that we've worked on a 28 square meter surface area per cow. That's pretty high. And it means that we were limited from the indoor stalls. That was 28 square meters. And so for those surfaces, we know that those were limited to indoors and not outside. But we know that also in the literature, according to the frequency of use and number of animals, it could reach 28 square meters per cow. So the surface area was higher. So there's probably an accumulation that can be done between the cow needs and the economic side of things on the long term to make the concept a little bit more attractive. Thank you, Sébastien. You provided a lot of information there, so thank you. The second question on engineering, around engineering actually, and maybe you answered partially, but Stéphane, I'd ask you the question if you want to complete. Basically, we see that we've got Sébastien's answer, which seemed to indicate that there was a lot more work that needed to be done at the end to optimize the concept. But basically, what are the next steps that need to happen, in your opinion, before favoring the adoption and the implementation on farms as such? Well, on my end, I know that nobody will really question that, but for me, it's the volumes of water that need to be managed. If we look at the surface volume, even if there are no cows, but you've got a huge surface, well, then you've got water, and the water will land on the structure and melt or drip, and then we can't treat liquid entirely, so we're not respecting rejected water to the environment. And so we're looking at our storage structure. that for me, it's a question of volume. Will we have a bigger structure, et cetera, et cetera? So I think in the future, what needs to happen is that we need to attempt to see how we can reduce the volumes of water that need to be managed. So the contaminated levels of water that need to be managed. So if we open up a door and we say, okay, that's where we're going to go. Well, the question is 28 square meters per cow necessary? And so there are lots of discussions. And, you know, when we design how many hours the cow will be there, it's not a question of square meters. I would say to people who are involved, I'd say, listen, try to find the optimal, but the optimal, you know, you want to not have too much surface area per cow, so that'll limit the quantity of water. And then if we can sort of start to take a portion to eliminate the rest and precipitation that's not going through our stall, well, it'll be less water to manage, and it'll be in the storage structure. So my message basically is that we need to try to reduce our surface area. And is there a way of putting like you know, something where you say you've got less surface area exposed to the weather? And then if we suppose that we can't treat things adequately with the mixes that Sébastien has said, well then, you know, eventually it'll be an exercise area, but we have to understand that water can't be treated adequately, and so maybe we'll decrease costs, and then we'll have the biofilter, and we'll have, you know, recovery, but we'll look at a cheaper substrate, and maybe we'll be able to reduce costs at that level as well. So basically we have to reduce the surface where water can land and have less water to manage. And so essentially that's, you know, my 2 cents worth. That's great. Thank you. It's always great for researchers when there are some questions that need to be answered at the end of the day. Okay, thank you very much. So we have at least one question in the chat. And so do cows have access? If cows have access to exercise areas, do they change their production in milk? Is there a decrease in stress, or is there some sort of other impact on consumption in cattle if they go out to the exercise area? Okay, well, those are factors that we didn't look at. I'm thinking about dairy production, for example. We could have, you know, gotten some information. It could have been interesting to look at, but basically we went step by step. So for the cow herself, itself, and its welfare, what happens for the cow's welfare? How does the cow perceive going out? And after that, if we really want to be interested in what's going on, I mean, there are different steps and other indicators to look at for producers to look at the effect of exercise. Now, we have addressed a number of the challenges that were already brought up, and we are looking at something fairly positive, all things considered. Okay, thank you very much. We seem to have just a few minutes left, and we've got another question. So here's the question. The producer said they got their herd to walk every day, and that this producer saw positive effects. Given that the cows in an exercise area are no longer stimulated, well, could it be a practice to recommend? I don't know who wants to address that question.
Elsa pourra contribuer aussi. Pour moi, je vais juste commenter
As
sur
for me, I just want to talk about the novelty aspect. Well, that takes place when they have an exercise yard. Now, the experiences we've had with these exercise yards were very simple yards, really want to remain very basic, but afterwards, of course, there could be, we could add to this. We could, in those exercise areas, we could add something to stimulate the animal's interest for this area and put things, these are things we'll have to test to see if the exercise yard in itself is enough. Well, the cows, when we put them outside, well, yeah, they will have some behaviors. They won't just stay there and do nothing. So we give them the opportunity to behave as they wish, and they move a bit, they do a little bit of socializing and just staying put in their exercise yard. And if we add other types of other things, will it stimulate them more? Again, it's step by step to say, yes, we already have a first thing with the exercise era. That's one stimulus. By adding more stimulus, could it also stimulate them to do other things, motivate them? And now for the walking part, I'll leave Elsa talk about this. Is it worthwhile? Yes. Well, we've thought that the results were quite impressive. We improve the movement score on a scale of 5. It's enormous. And we said that there wasn't a big difference in the fact that it would still take a lot more cows to continue on, but it's not the first trial we tried. So increase locomotion on animals that usually don't walk, to have a facility to handle these animals. These are results that are very interesting, and it becomes interesting because we can put this in their routine, meaning the idea is the cows don't just go out just to go out. We can clean the stalls, the barn. We take them out in the morning, we bring back. We measured some interesting results. For instance, on the thermic stress, we realized, no, it doesn't have a negative impact. So all these issues, there's still some research to be done, but our first results show that, in fact, yes, it was beneficial. Of course, it has to be well done. So we'll continue to work with our engineering colleagues to see what are the other benefits, and also on the environmental front, what are the benefits. All right. Elsa, I'd like to know if we'd like to work with you. And that's the question. Are we interested in working with you? That's the issue. You know, is there something you want to share with the general public today? I think you seem to form a good team. There's a lot of questions to answer. There seems to be interesting results and interesting dynamics. So we're ending our webinar. So I wanted to thank our 5 panelists and the students who presented their papers. I'd like to thank all those who attended this webinar today. So the next one of this series will take place on the 2nd of March at 1 p.m. with, well, you can see on the screen, and with Dr. Trevor DeVries. So having said so, thank you, everyone. And we hope to see you at our next events. Thank you. Have a pleasant day. Thank you very much. Thank you. Thank you.